when we are talking about the organic chemistry? Yes or no? Just understand, just understand that organic chemistry basically deals with all the carbon and its compounds. Organic chemistry deals with carbon and its compounds. Okay? So you have to understand that there are different types of carbon compounds. Carbon is one of the element which forms more or large number of organic compounds. Okay? Large number of organic compounds. So carbon is one element which would form large number of organic compounds. Are you understanding? Right? Secondly, you have to understand why does it form? So the question arises, why does carbon forms large number of organic compounds? Large number of organic compounds. So that's the question that arises the first. That why does carbon forms large number of organic compounds? That's a very important question. Okay. That means that understand. So basically you have to understand that carbon possesses two types of properties. One thing, that carbon is tetravalent. Carbon is tetravalent. Are you understanding, Ayush? Tetravalent means it has valency 4.
Four valence.
It has valency 4. Yes or no? And valency 4 means what? Valency 4 means what? That carbon's atomic number is 6. Atomic number means the number of protons. What is atomic number? Atomic number means the number of protons. The number of protons. Yes or no? So more the number of protons.
Yeah.
So, and we also know that in a neutral atom, the number of protons are always equal to the number of electrons. That's what we know, isn't it? We have understood that in a neutral atom, the number of protons are always equals to the number of electrons. Why is that so? The reason is that when we talk about an atom, we know what? That everything in nature is made up of atom. Everything. So if you talk about a table, you know that table is also made up of atoms. Small atoms. Though we are able to see it or not, that's a different story. But those everything in nature, yeah, that means matter is made up of atom. All right. So that's the concept. So you have to understand that matter is made up of atom. An atom is very small. So I hope you're understanding that every atom in nature is neutral. Yes or no? And why is that so? Because
Yeah.
every atom contains equal number of protons. Every neutral atom consists of equal number of protons and electrons. Equal number of protons and electrons. Are you understanding? So every atom consists of
Yeah.
equal number of protons and electrons. And what is the charge of one electron? What is the charge of one electron? The charge of one electron is plus 1.602 into 10 raised to the minus 19 coulomb. This is the exact value of the charge of an atom, of an electron. So what do? We understand that electrons are negatively charged. So it is minus 1.602 into 10 raised to the minus 19 coulomb. Do you understand? So when we are talking about the
Yeah.
charge of an electron, so this is my absolute charge. Absolute means the exact value of the charge of an electron. And the value of the charge of proton, the value of the charge of proton, that shall be plus 1.602 into 10 raised to power minus 19 coulomb. This is also the absolute charge. What do you mean by absolute charge, Ayush? Absolute
Exact.
charge means the exact value of charge, that this electron would carry exactly this much amount of charge. Okay, that is plus minus 1.602 into 10 raised to power minus 19 coulomb. Every proton would carry plus 1.602 into 10 raised to the power minus 19 coulomb. Are you understanding? Now understand. But
Yeah.
there is also one thing called which is the relative charge. There is another type of charge which is also called as the relative charge. Now, what is a relative charge? Relative charge means a comparable charge. Okay, a comparable charge. What do you mean by a comparable charge? Like, for example, if you say the value of one electron's charge is minus 1.602 into 10 raised to the minus 19 coulomb. But this is such a big number. It is such a big number that you won't be able to understand that, how to write down this number every time. Okay, so what do? We say that the charge of one electron is this, and the charge of one proton is plus 1.602 into 10 raised to the power minus 19 coulomb. So, do you understand if I divide it out? What am I doing? I am dividing, I am comparing the charges of electron and the proton. What do I get? I get minus 1.602 into 10 raised to the power minus 19 over plus 1.602 into 10 raised to the power minus 19. That would mean that, if I see this, they get cancelled out. And what am I left with? I say that the charge of one electron is minus 1 over the charge of one proton is plus 1. This is a very, very important concept to understand in all the chemistry parts, whether it is the mole concept, whether it is your organic chemistry. You have to understand this part that, let's suppose when I say, the number of toffees that Ayush and Shubhangini has is in the ratio 2 is to 3. So this is the ratio of the toffees. I hope you're understanding. 2 is to 3 would mean what? That I could have 8 is to 12. That means I could have originally 8 toffees. 8 toffees are with me. Yes or no? And 12 toffees are with me, are with you. So exact toffees are 12 and 8. But if you take out their ratio, that is 2 is to 3. So does that ratio mean that I have 2 toffees and you have 3 toffees? No, that means you have 12
No.
toffees and I have 8 toffees. So actual charges, the actual values of toffees that I have is 8 and 12. But if I take out the ratio, it would be 2 is to 3, isn't it? So you have to understand it this way. I hope you're understanding. Okay? So
Yeah.
when I say the ratio of the charges is one proton's charge is plus 1, this is my relative charge. I hope you're understanding. And relative to what? Relative to comparable to electron. That if you compare the charge of the proton with respect to electron, it would be plus 1, and electron's relative charge would be minus 1. Are you understanding my point? Okay. But the
Yeah.
absolute charges, the exact charges are something else. This plus 1 and minus 1 is just going to tell me the the ratio of the proton and the electron. I suppose you're understanding. Okay? That is the concept. So now when I say that, at this particular point, if I write down 10 protons and 10 electrons at the same point, at the same point, I'm placing, let us suppose, 10 electrons and 10 protons. So what is the charge of one proton? Plus 1. So thereby, what would be the charge of 10 protons? Plus 10. This is not the actual charge. This is the relative charge. Okay? And that would be plus 10. And what would be the charge of 10 electrons? It would be minus 10. So the net charge would be at this particular point. Net charge at point A. Net charge at point A would be would be plus 10 minus 10 equals to 0. So when I say, carbon atom is neutral, when I say carbon atom is neutral, and I also say that, its atomic number is 6. Are you understanding? When I say its atomic number is 6, what does that mean? What does that mean? It means that, it means that it has 6 protons. And in order for the carbon atom to be neutral, I suppose you're understanding that, it has 6 electrons also. Are you understanding my point?
Yeah.
Okay. And thereby, every carbon atom is what kind of carbon atom? Every native. or every free carbon atom is neutral. Okay, so it would have 6 protons, that means plus 6 charge it is carrying, and plus 6 electrons, that means minus 6 charge it is carrying in the form of electrons. I suppose you're understanding. Okay. Now, when I
Yeah.
look at these electrons, so what is the structure? What is the nature of the carbon atom? The nature of the carbon atom is like this, that it has a nucleus, and the nucleus consists of 6 protons and 6 neutrons. Okay, we are talking about the most abundant type of carbon. We are talking about the most abundant type of carbon, which is carbon 12. I'll tell you one more thing on this. And there is the electrons are revolving around it. Okay, the electrons are revolving around it. So the electrons are revolving around it in the K shell and the L shell. Okay, the electrons are revolving around it in the K shell or in the L shell. Okay, so how do you think that these 6 electrons would be, spread across the two orbits? So we would have 2 electrons in the K shell and we would have 4 electrons in the valence shell. Are you understanding my point? So we would have 4 electrons in the L shell. And I suppose you can see that L shell is the valence shell here. L shell is the valence shell.
Yeah.
That means it is the last shell. So you will say that if you look at the atom of carbon, it would have 4 electrons, one, two, three, and four. 4 electrons in its valence shell. Are you understanding? So we have 6 protons in the nucleus, and there are also 6 neutrons in the nucleus. So what is this nucleus doing? The nucleus has a positive charge because of all the protons. The nucleus has a lot of positive charge because of all the protons. And neutrons, they are doing nothing but they are just contributing to the mass. And also, in a certain way, neutrons are also responsible for the stability of the nucleus. How it is responsible for the stability of nucleus, that you will do it in physics. But for now, it consists of 6 protons, and 6 protons give it positive charge. And there are 6 neutrons also. So I would say protons give the nucleus positive charge, give the nucleus positive charge, and and neutrons give the nucleus only mass. Okay, so neutrons are responsible for giving the mass to the nucleus, and protons is responsible for giving both charge as well as mass. So protons give everything to the nucleus. That means protons increase the mass of the atom also, and protons also are responsible for the positive charge of the atom, of the nucleus of the atom. But neutrons are also very important. It's not something that you can deny the importance of neutrons. Neutrons, though they are neutral, okay, neutrons are neutral. Neutrons are neutral, but they are adding mass. And also, neutrons are very, very important to keep the protons together, Ayush. I hope you're understanding. Do you realize that, in a nucleus, if this is my nucleus, do you understand that protons both are positive? So don't you think that they should repel? So who keeps these protons and protons together inside the nucleus? Because this nucleus, we say that, all the positively charged protons are, placed in this particular part. All the protons are placed in this particular part. Are you understanding? So in the nucleus, how are these protons actually placed in this particular nucleus, small nucleus? So there are neutrons in between the protons, and these neutrons help to keep the protons together. So you understand that between every 2 protons, there are neutrons. And why is that so? Because neutrons provide stability. Neutrons provide stability to nucleus. Are you understanding my point? So the importance of neutrons
Yeah.
is got that it is not just giving mass to the nucleus, but it is also imparting stability to the nucleus. Are you understanding my point?
Yeah.
Okay, so this is very, very important. So when I say that, carbon is very stable compound, so one reason for the stability of carbon that it has equal protons and equal neutrons. That is one reason for the stability of carbon. And that is why carbon is more abundant in nature. And that is why carbon forms a lot of compounds. But two primary reasons is that carbon has four valence electrons. Carbon has four valence electrons. Carbon has four valence electrons. So when carbon has four valence electrons, it can at once form four bonds. Like for example, if I take an example of methane. So normally what do we see? We see carbon is here. And in the Lewis dot structures, what do we do? In the Lewis dot structures, what do we do? We say that carbon has atomic number 6, configuration 2 4. So we know that in the bond formation only valence electrons participate in bonding. Only valence electrons participate in bonding. Okay, only valence electrons participate in bonding. I hope you're understanding. And when only valence electrons
Yeah.
participate in bonding, so what do we do? Around carbon, we will draw only four electrons. Are you understanding my point? And it is combining with hydrogen also, and hydrogen is also a non-metal. So hydrogen is also a non-metal. Are you understanding? So what do we have? We have hydrogen is atomic number 1. Atomic number is the number of protons. That means hydrogen has one proton. And in a neutral hydrogen atom, there should be one more electron. So every hydrogen is bringing with itself one electron. And when they share, so hydrogen applies force of attraction not only on just its own electron, but also on the electron of carbon. And same is the case with carbon. Carbon would have its own nucleus. So the nucleus of carbon is not just applying force on the electron of carbon itself, it is also applying force on the electrons of hydrogen. Are you understanding? Okay, so that is the concept.
Yeah.
So when we are talking about this particular part, I suppose you're understanding that carbon is going to form bonds with hydrogen, with this hydrogen, with this third hydrogen, and with the fourth hydrogen. So one carbon at once can form four bonds. It can share its electrons with four different atoms if it is forming only single bonds with all of them, and thereby carbon can form. So how do we show this? We show it by this method. So we say carbon is forming four bonds. So the very first property that why so many compounds of carbon are known in nature. So one thing you have to understand that carbon has tetra. Tetra means four. Tetra means four. So carbon has tetra valency. Okay? Carbon has tetra valency. Second reason that we have is the property of catenation. That carbon possesses property of catenation. Next reason that why carbon possesses and forms so many compounds is the property of catenation is possessed by carbon is possessed by carbon. So property of catenation is possessed by carbon. Okay, now what is catenation? The catenation property would mean what? The catenation property means the catenation property means self-linking property. Catenation means self-linking property. Self-linking property of carbon with itself to form linear branched, okay, or cyclic and saturated and unsaturated structures. Saturated and unsaturated structures. Saturated and unsaturated structures. This is called the property of catenation. So, and this catenation property is maximum in carbon. Okay, understand why the catenation property is being possessed by carbon. I'm coming to that, but I hope you're understanding that the catenation property is maximum. This catenation property is maximum in carbon. This catenation property is maximum in carbon. Okay, so when we are talking about the catenation property, I hope you're understanding that the catenation property is shown maximum by carbon. Then the other elements also show catenation, like silicon. Like silicon, it also shows catenation. Okay, there is another element which is called phosphorus that also shows catenation. There is another element which is called oxygen that also shows catenation. But the extent of catenation in silicon, phosphorus, and oxygen is very less extent of catenation. So there is a very less extent of catenation in these elements, and the extent of catenation in carbon is very, very high. Carbon can combine to itself, it could form, like it could combine with straight chains. So this single line represents a single bond, whereby one electron belongs to one carbon and the another electron belongs to another carbon. I hope you're understanding. So carbons would join to form straight chains. So this is a linear chain. In the linear chain also, carbon can combine with itself, not just by forming single bonds, it could at different places form double bonds also. So it has a double bond linear chain. It has a double bond linear chain. I suppose you're understanding. There could be a triple bond also in the linear chain. So long chains, and it is understood, it has been found that approximately 586 carbon long chain has been found, and even more than that. So I hope you're understanding that carbon can keep combining with itself, and 586 carbons can combine to itself without breaking. Ayush, I hope you're understanding what I'm trying to explain you. That catenation means the self-linking property that carbon would connect to itself and will continue connecting. Are you understanding my point? Okay, right?
Yeah.
Okay, so that is the concept. So when I'm talking about catenation, so this is an example of linear chain. So linear chain could have all single bonds. Sometimes it is also possible that the carbon chain would have carbon-carbon chain, and at the side there would be some side carbons also. The side chains could be there. These side chains could be as small as one carbon. They could be as large as 1,000 carbon. So this is an example of branched carbon chain. Branched carbon chain. Are you understanding? Then what do we have in here? There could be a possibility that carbon might join to form rings. There could be three-membered ring. There could be four-membered rings of carbon, where obviously the valencies it is going to complete with hydrogen. The valencies it is going to complete with hydrogen. Carbon forms four bonds. So this carbon is forming one bond here, the second bond here, the third bond here, and the fourth bond here. I hope you can see, Ayush. So we have every carbon will form
Yeah.
and complete its valency with hydrogens. Okay? So it is going to form this particular part. So now what am I trying to show you here? That carbons are joining itself to form the rings. Four-membered ring, minimum it could be like minimum three-membered ring, because two carbons cannot form a ring. So it would be every carbon would form H. The remaining valencies would be completed by hydrogen. Are you understanding? So this is what we have. It
Yeah.
could be a six-membered ring also. Why am I showing you this? That you have to understand that when it forms like this, and then obviously the remaining valency is completed. So this is an example of the catenation property of carbon. That to how much extent carbon can connect to each other, okay, and form long ring chains, linear chains. Sometimes you also understand that sometimes it is also possible that in the chain there might be a double bond in the chain. There might be a double bond also possible in the chain. That is also one possibility. There could be a possibility that in a structure there are carbon chains, there are carbons, and to carbon, one ring chain, there is a linear chain. So in this structure, we have a linear chain also, and we can also see a ring. So carbon can combine in numerous ways. Okay, and this is called the catenation property. Okay, so self-linking property. Just see, carbon is connecting itself to just itself, carbon. So this self-linking property of carbon is called catenation. So it could form rings, it could form branches, it could form linear chains. Are you understanding? Different sized rings, small to 3-membered ring to 6-membered ring, and even more than that. Okay. Next, what do we have?
Yeah.
The question says, what is the reason of catenation? What is the reason of catenation? Okay. What is the reason of catenation? That why carbon shows so much catenation? What is the reason for the tremendous catenation property shown by carbon? So the reason here would be, just see, the reason here would be that small size. Carbon has a very small size. So because carbon has a very small size, what would that mean? What would that mean? That carbon, because of its small size, will form or forms very strong bonds. Forms very strong bonds. Okay, so carbon has a very small size and it forms very strong bonds. And thereby the long bonds could be shared. Now understand. So understand one thing. Like for example, if I have two atoms, one, this is the atom. So here I am trying to show you the overlapping of two small atoms. Are you understanding? So the electrons would be here somewhere in the middle. And if I show you the overlapping of two big atoms, so I hope you understand now that the nucleus consists of protons and the nucleus thereby is positive. Yes or no? And there are definitely the electrons exactly in the center. Now you tell me, once this
Yeah.
particular small atom, the bond is formed. So do you understand this is carbon number, this is A atom and this is B atom? Okay, in this small atoms overlapping here, do you see that the small atoms are overlapping? So do you understand that this proton, this nucleus is positive and the electrons are negative here in the sharing part? In this common part, what do you get to see in this area? Don't you see that the electrons are being shared? So I hope you're understanding that these nucleus is sending attractions to this electron because the electrons are negative and the protons are positive. And the A atom's nucleus is also sending its attraction to the A atom's nucleus is also sending its attraction to the electrons here in the center. So I hope you're understanding that these electrons in the center of the black atom sharing, don't you think that they are overlapping in such a small space that the nucleus is very close to them? Are you understanding? Do you see that in the black atoms overlapping, the nucleus is very close to them? Tell me. And when the nucleus is very close to them, don't you think that there is a lot of attraction? Don't you think that there is a lot of
Yeah.
attraction from the close? The distance is very less. So from a shorter distance, there is an attraction reaching from the positive nucleus to the electrons here in the center. Are you understanding? And which is why these electrons, so this bond between the two carbon atoms would be very strong because the attraction, what is the bond? Bond is nothing but an attraction. But that attraction is coming from this nucleus to this electron, from the positive nucleus to this electron. And since the positive and the electrons are very close, so this attraction between the electrons, between the shared electrons, between the nucleus and shared electrons is very high. And thereby, carbon carbon single bond is a very strong bond. I hope you're understanding. And thereby, when long chains of
Yeah.
carbon is formed, so every bond is equally strong. So none of the bonds can break, and that is why carbon is able to sustain such long bonds. I hope you're understanding. right? And that is why carbon can form different structures, whereby the bond is very, very strong. Now have a look here. This atom B dash, and this atom A dash. Don't you think that this A dash and B dash atoms are very big? So the distance between the nucleus and this
Yeah.
electron is large distance, and this distance also between the nucleus and this electrons is also very large distance. Are you understanding? And when this distance is too large, do you think that from a larger distance the attraction reaching the electrons, this attraction reaching the electrons, wouldn't that be a less attraction? And the attraction is less,
Yeah.
that means the bond is weak. And when the bond is weak, so now do you understand that, when such a big atom forms overlap, when such a big atom overlaps, what do you think would happen? What do you think would happen? The
It'll make a
catenation
weaker
property would look
bond.
something like this: that big overlap, big atoms overlap, another overlap, another overlap. But every bond is a weak bond. So such a big bonding, such a big chain will not be able to sustain, and this big bond would break. This longer bond would break because of less attraction. But when carbon combines, carbon forms a strong sharing, and the attraction is reaching on both the electrons in a very, very high amount, which is why the strong bonds are sustainable and they can form long chains without breaking. Are you understanding? So carbon can form side chains also, it can form rings also. I hope you're understanding just by sharing. Yes or no?
Yeah.
Okay, so the reason for the very high catenation tendency of carbon is its small size and the strong bonds it forms. The small size and the strong bonds that it forms. Strong bonds that carbon forms. And carbon can combine up till 900 atoms. So certain data tell it is 586, certain data tell it is 900 atoms. But obviously carbon has the property. Then you see next to carbon would be silicon, would be silicon. Definitely it is very less with regards to carbon, but silicon can combine with itself up till 14 atoms. Followed by phosphorus, it can combine up till 4 atoms, and followed by, um, I would say, ozone or oxygen that could combine up to 3 atoms. So the best example is O3, ozone molecule. Okay, so this is the order of the catenation of the elements. So order of the catenation of elements. Are you understanding? Okay, so
Yeah.
this is the order of the catenation of the elements, right? So that's the concept, right?
Yes.
Right? So this is catenation. So that is why we talk about the organic compounds. Organic compounds are compounds which contain or carbon. So what are organic compounds? Let's discuss them first. See, organic compounds, you have to understand all the compounds which we extract from living beings, which we extract from living beings. That was the old definition. This was the old definition of the organic compounds. That all the compounds which contain, you know, all the compounds which have been extracted from living beings are called organic compounds. But the new definition says that all the compounds which contain carbon, necessarily carbon, and one carbon to hydrogen direct bond, only then it would be an organic compound. That's the new definition. That every organic compound must contain carbon, and it must also contain one carbon to hydrogen direct bond. So, for example, if we are saying that the element consists of carbon, but it does not contain the CH direct bond, then you will not classify it as an organic compound. You will not place it in the category of an organic compound. I hope you're understanding. So, when we are talking about the organic compounds, that was in the old definition, but this old definition was discarded because nowadays we could also prepare the organic compounds in laboratory. Okay, and the first organic compound that was prepared in laboratory was urea. This was my first organic compound prepared in laboratory, prepared in lab, prepared in lab. That was urea. The formula of urea would be NH2CO NH2. This is the formula of urea. And this was prepared by Frederick Holler. This was prepared by Frederick Holler. I hope you're understanding. So Frederick Holler was the scientist who actually prepared the first. So I tell you one example. Okay. That most of the organic compounds have to have contain carbon and one, at least one. Okay, at least there could be many, but at least one carbon to hydrogen direct bond. Okay, direct carbon to hydrogen bond. That must be there. Only then you will classify it as an organic compound according to the new definition. According to the new definition. Yes or no? What do we have in here for carbon?
Yeah.
Just understand. So we have at least one carbon to hydrogen direct bond. Like for example, if I say HCN. So if I draw the structure of HCN, just see carbon's atomic number is 6. So configuration is 2, 4. Hydrogen's atomic number is 1. So configuration is 1. That means it has 1 electron in its K shell. And nitrogen is atomic number 7. So its configuration is 2, 5. That means in the K shell it has 2 electrons. And in the L shell it has 5 electrons. So when you have 1, 2, 3, and 4 electrons, and hydrogen has 1, so we have only one hydrogen in the hydrogen cyanic acid. And nitrogen is how many? Nitrogen needs 3 because nitrogen is atomic number 7. So it is bringing with itself 1, 2, 3, 4, 5. So 5 blue electrons nitrogen is bringing with itself. And carbon is bringing with itself 1, 2, 3. Okay? Now, how does it overlap? So nitrogen would form this bond. Nitrogen would take away the 3 electrons of carbon. So nitrogen's nucleus is here, isn't it? And it is sending its forces of attraction to not just its own blue electrons, but it is also sending the force of attraction to its red electrons. And these red electrons are actually belonging to carbon. Okay? So what do we have in here? We have another bond. So hydrogen is also sending its force of attraction on carbon. So carbon would also form the bond with hydrogen and nitrogen. So if I look at the structure, don't you think it is HC triple bond N? Yes or no? Right?
Yeah.
And here we have carbon. So one condition is fulfilled that it must contain carbon. And we also have a direct carbon to hydrogen bond. So thereby we would classify that HCN is an organic compound. Okay? But now I'll tell you one thing that if you look at NaCN, NaCN, what is the name of NaCN? Na is sodium. And Cn is cyanide radical, so the name would become sodium cyanide. But now you see, if I look at the structure of NaCN, it would be Na positive and C triple bond N negative. And there is a force of attraction between Na and Cn. Okay? So I hope you're understanding that this
Yeah.
compound contains carbon. So one condition is fulfilled, definitely. But do you see any hydrogen in this compound? Ayush, no.
No.
So that means
No.
it has carbon. So normally, if we simply say that all the carbon containing compounds are organic compounds, that is not true. Sometimes there are organic compounds which contain carbon, but they do not have hydrogen. So you will not classify them as the organic compound. Are you understanding? So this would not be an organic
Yeah.
compound. So a general statement that comes across is that cyanides are not organic compounds. Cyanides are not organic compounds. Are you understanding? And similarly, if I
Yeah.
draw the structure of carbonates, so for example, if I say the H2CO3 structure, H2CO3, this is my carbonic acid. This is my carbonic acid. So if I draw the structure of carbonic acid, the structure of carbonic acid is like this. So carbon has 4 electrons, so 1, 2, 3, 4. Because carbon has atomic number 6 again, configuration 2, 4. So it has 4 valence electrons. Because it has 4 valence electrons, so it has 3 oxygens also. So it has 3 oxygens also. And oxygen has atomic number 8, configuration 2, 6. So every oxygen has 6 valence electrons. Yes or no? Every oxygen atom will
Yeah.
have 6 valence electrons. So we would have 1, 2, 3, 4, and 5, 6. So what do we have in here? So do you think that this oxygen needs 2 electrons? So it bonds with carbon. And the structure here would be there would be other 2 oxygens also because there are 3 oxygens here. So the 3 oxygens would combine like this. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. And the hydrogen is also here. And the hydrogen is also here. So do you understand that this hydrogen will complete its duplet by combining with oxygen? And this
Yeah.
oxygen will combine once on the one side it is combining with hydrogen, and on the other side it is going to combine with carbon. So it is going to form the bonds like this. And this is how the oxygens fulfill their octet. And thereby the oxygen, the carbon would take 2 from every oxygen. So just have a look here. So in this bond, in this particular bond, just tell me. In this particular bond, there is this black electron which is coming from oxygen, and there is this red electron which is coming from carbon. So we have 2 electrons here, one from oxygen, one from carbon, single sharing. Okay? Again, here in this bond between oxygen and carbon, 1 electron, red electron from carbon, and the black electron is coming from oxygen. So again, single sharing. So carbon has 1, 2, 3, 4. 4 electrons coming from itself because that's the 4 electrons of carbon only. But oxygen's electron would be 1 here and 1 here. So 2 and 3 and 4 from this oxygen. So don't you think carbon has also completed its octet here? 1,
Yeah.
2, 3, 4, 5, 6, 7, 8. And in this full process, what is exactly happening? That carbon, if I look at the structure in detail, it looks something like this. That carbon is forming a double bond with this oxygen, an O and then H, an O and then H. And what is this oxygen doing? It is taking 1 electron from hydrogen and 1 from carbon. So that's how carbon is taking 2 electrons, oxygen. And this oxygen is also taking 2 electrons from 1 from carbon and 1 from hydrogen. So what do we see in this compound? Do we see a carbon? Yes, carbon is there. But do we see a direct carbon hydrogen bond? No, we see a hydrogen, but that hydrogen is connected to oxygen. That hydrogen is connected to oxygen. Are you understanding? And
Yeah.
which is why, I hope you're understanding, which is why
Not an organ.
it is not an organic compound. So there is a certain definition of an organic compound. So no doubt we had a previous definition which says that all the compounds which we can derive from the living plants and animals, living beings, was an organic compound. But now the correct definition is this, because with the advancement of technology and lab work, we have been able to prepare every organic compound in the laboratory. So even if, for example, an acid is found in you know in some fruit, we can also prepare that acid in the laboratory. So we don't need to extract it from the living beings now, but the definition holds true according to the new definition. Are you understanding my point? Okay,
Yeah.
right? So now, based on that, we understand that those organic compounds, those organic compounds which contain only carbon and hydrogen, which contain only carbon and hydrogen are called hydrocarbons, are called hydrocarbons. Are you understanding my point? Right? They are called hydrocarbons. Right?
Yeah.
So we have classified hydrocarbons, according to three categories. There are lots and lots of hydrocarbons, but pure hydrocarbons we have characterized into three categories. One would be alkanes. There is a specific name for alkanes which is called paraffin. You must have seen the candle waxes, the candle wax. And that candle wax is nothing but just a paraffin wax. I hope you're understanding. So the wax that you get in the
Yeah.
Vaseline is an alkane. The wax which you get in the shoe polishes is also an alkane. Are you understanding? So they are also called as paraffin waxes. So alkanes have a different name called as paraffins. Another category of hydrocarbons is alkenes. Most of the alkenes that you see, most of the alkenes that you see would be would be olefins. So you must have seen sunflower oil, okay, the refined oil and the olive oil and groundnut oil and different types of oils that you have, sesame oil. All the oils by nature are alkenes. Even for that matter, the petrol and the diesel, they also have a higher percentage of alkenes in them, right? Though the major component is octane, but it also has certain amount of alkenes in it. And the last compound is alkynes. Okay, the last compound is the type of hydrocarbon would be alkynes. And alkynes, as such, they have no specific name, no common name for them. They're just called alkynes. And every hydrocarbon has a general formula. So, what is the general formula? What is the general formula? The general formula of alkanes is CnH2n plus 2. The general formula of alkenes would be CnH2n. I'm explaining every part in detail. Okay, don't worry about it. But it is just a basic overview that you know how many types of hydrocarbons do you have. And we also have alkynes. So we would have CnH2n minus 2. Okay, so N here this N. N basically in every general formula means the number of carbon atoms. Right, Ayush? Number of carbon atoms. Okay? Yes or no?
Yeah.
Right? So N in every example would mean the number of carbon atoms. That is N. Right? So now, for example, if I say that the alkanes, and alkanes are also called as a different name. They're also called as saturated hydrocarbons. They're also called as saturated hydrocarbons. And thereby alkenes and alkynes have a common name. They are also called as unsaturated hydrocarbons. Unsaturated hydrocarbons. Okay. So what do you mean by saturated? Saturated would mean that all the valencies of carbon are completed by hydrogen, or maximum valencies of carbon are completed by hydrogen. So that is what you mean by saturated. So all the valencies or maximum valencies of carbon are completed by hydrogen. Whereas in alkenes, you get to see a double bond. So not all, few valencies of carbon are balanced by hydrogen, but there are other elements also which are combining with carbon. And it's not just hydrogen completing the valency. So thereby they are called as unsaturated. That means if I want to remove those extra elements, I can always replace those extra elements with hydrogen. So I'm going to explain you how it basically works. But for now, just understand that alkanes would be classified as an saturated hydrocarbon, and alkenes and alkynes are also called as unsaturated hydrocarbons. So in alkynes, we have the
Yeah.
triple bond somewhere in the chain. It could be any long chain, containing 5, 10 carbon, 12 carbons. But in that carbon chain, you have to understand that at least at one particular place, we would be having a triple bond. That would be definitely an alkyne. That particular compound would show you the properties of the alkyne. If, for example, we are seeing a double bond here, so then no matter how long the chain it is, no matter how long the chain it would be, it would show you the properties of alkenes. Alkenes. And if it is a long chain where only single bonds are there between every two carbons, where there is only single bond between every two carbons, okay, that would be that would be what? That would be a single covalent bond, and they would always be called as alkanes. Are you understanding?
Yeah.
Right? So three types of hydrocarbons primarily: alkanes, alkenes, and alkynes. Understood? Right? Now just have a look. So just understand. So if I write down the general formula of alkanes, now let's discuss a little bit of alkanes. If I say that the general formula is CN H2N plus 2. That means how many number of hydrogen atoms do you think we have? How many hydrogen atoms do you think we have? We have two more than double the number of carbon atoms. Like for example, if I have N equals to 1. So everywhere in the formula, I would just substitute N as 1. And I will get C, and the place of N I'm putting 1, H 2 times 1 plus 2. So it shall be C times 1 and 2 times 2. 2 times 1 would be 2, 2 plus 2, 4. So it shall become CH4. Similarly, if I put N equals to 2 in the formula, what do I get to see? C, in place of N, I'm going to place 2. H, again in the place of this N, I'm going to place 2 because I've assumed by myself that let's suppose N is 2. And in order, I'm substituting. So 2 times 2 plus 2. Everything else remains the same, Ayush. But just in place of N, I am changing the values. I hope you're understanding. So that would be C2H6. Because 2 times 2, BODMAS rule says do the multiplication first and then you add 2. I hope you're understanding. Right?
Yeah.
Then you continue with the series. Up till 4 or 5 compounds you calculate. You get N equals to 3. You get N equals to 4. And you calculate N equals to 5. And you can keep carrying on doing this calculation up till infinity. And N could be 100, 1,000, any number. But why am I showing you this calculation? It's important. So in place of N, you put 3 in this place of N. And you have 2 times 3 plus 2. And it shall be C3H8. Are you understanding? It would be C3H8. Then you have C4, C4 and H 2 times 4 plus 2. That would be 2 times 4 is 8, 8 plus 2 10. So that shall become C4H10. If you put C under the subscript of C, you're putting 5. So it shall be 2 times 5 plus 2. So that shall be C5H. 2 times 5 is 10 plus 2, 12. Yes or no? So what are these?
Yeah.
These are all my alkanes. I hope you're understanding.
Alkene.
All of them, alkanes. These are all alkanes. Why? Why are these alkanes? Just tell me. These are all alkanes because down the group series, these are all alkanes. Why? Because they're all following a general formula of alkanes. They are all following the general formula of alkanes. Are you understanding? So when they're all
Yeah.
following the general formula of alkanes, what would that mean? That this is a homologous series of alkanes that is generated. Homologous series of alkanes that is generated. So what do you mean by a homologous series? A homologous series means a series of compounds which are following a single general formula. So do you see that all of these compounds have been derived from a single general formula, and which is CnH2n plus 2. Are you understanding my point? So, what is homologous series? Homologous
Yeah.
series is a group of compounds. It's a
Series,
series
series,
of
series
compounds.
of compounds that follow a general formula, single general formula.
Exactly. Series of compounds that follow a single general formula. Single general formula. Okay? And thereby, they would all belong to one family. So I would call it as an alkane family. That all the compounds that belong to this particular series that have followed this particular formula, they would all carry same chemical properties. So all the compounds, all the members of this homologous series, or not of this, of every homologous series, all the members of a given, all the members of a given homologous series, all the members of a given homologous series have same chemical properties, have same chemical properties. The physical properties could be different. That means they could be seen in a different way. Some could be liquids, some could be gases. That's a different story. But they would all follow a same chemical formula, a same chemical properties, right? So they would have the same chemical properties, but different physical properties. But different physical, but different physical property here at the top. Okay, they follow different physical property. So physical properties are different, but chemical properties are same. Okay, right? So what is a homologous
Yeah.
series? Okay, it is a series following a general formula. Now every compound, so you can understand that a homologous series could be as long as possible, isn't it? Every homologous series could be as long as possible. You keep on increasing the value of n, and you keep getting the compounds. So basically, every member of this homologous series is called as a homologue. Homologue. Okay, what is every member called? Every member of the series is called as a homologue. So I would say this is my first homologue, CH4. C2H6 shall be my second homologue. C3H8 would be my third homologue, and so on. Okay? And now just see, if you move from one particular homologue to the next homologue, what do you get to see? Just see. Do you see that there is an increase in one carbon? You move from carbon CH4, so CH4 has one carbon, and C2H6 has two carbons. CH4 has one carbon, and C2H6 has two carbons. So how many carbons are more in C2H6?
One.
One. And CH4 has four hydrogens, and C2H6 has six hydrogens. So how many hydrogens do you think are more in moving from CH4 to
Two.
C2H6? It would be two hydrogens. So can I say that there is a gap of CH2 group between the first homologue and the second homologue? I hope you're understanding. Between the first homologue CH4 and between the just next homologue, that would be C2H6. So there is a gap of CH2 group. Are you understanding? Right? Then again have a look. If you move from C2H6 to C3H8, again tell me, don't you think that C2H6 has two carbons and C3H8 has three carbons? So there is an increase of one carbon. And C2H6 has six hydrogens and C3H8 has eight hydrogens. So there is an increase of two hydrogens. So don't you see that
CH2.
between two groups, again, there is a gap of CH2 group? Okay, so
Yeah.
what do we say? What do we say? That between every two consecutive homologues, between every two consecutive homologues, there is a gap of there is a gap of CH2 group between two consecutive homologues. Between two consecutive members of the series, there is a gap of CH2 group. Okay, so between two consecutive homologues. Homologues means members. Between two homologues, consecutive homologues, there is a gap of there is a gap of CH2 group. Are you understanding? Right? And what is the mass of
Yeah.
CH2? What is the mass of carbon? It is 12, the mass number. And the mass number of hydrogen of one hydrogen is 1. So 1 times 2, that's 2 because there are two hydrogens here. So what is 12 plus 2? 14. So if you look at the mass of CH4 and if you look at the mass of C2H6, just have a look here. What is the mass of carbon? 12. For one hydrogen, it would be 1. So for four hydrogens, it would be 4. So don't you think the mass shall be 16? And for
Yeah.
C2H6, it would be 2 times 12 because there are two carbons, and for every carbon, the mass is 12. And there are six hydrogens, so the mass of every one hydrogen would be 1. So for six hydrogens, it would be 6. So don't you think it shall be 1 times 6? So when you add it up, you get 24. 2 times 12 is 24 plus 6. So the mass shall be 30. Now have a difference, have a look here. What is the gap between the mass of 16U and 30U? What is the mass difference?
14.
14U. And why is that mass difference arising? Why is that mass difference arising? Because there is a gap of CH2, isn't it? So we have discussed what is a homologous series. A homologous series is actually a series of compounds which are following a general formula. Every member of the homologous series is called as a homologue. Okay, every member is called as a homologue. I hope you're understanding. And the difference between two consecutive homologues would be CH2. Okay, and the mass difference would be the mass difference shall be of 14U. Are you understanding my point? Okay.